Have you ever looked up at the night sky, at that vast velvet blackness dotted with countless stars, and felt a sense of profound wonder? We see a universe that appears serene, almost eternal. But what if that familiar cosmic tapestry was about to change in the most dramatic way imaginable? What if the unseen force that governs the very expansion of space itself suddenly decided to step on the accelerator? This isn't just a fanciful thought experiment. It touches upon one of the deepest and most perplexing mysteries in all of science. We live our lives on this tiny blue-green world, largely unaware of the colossal cosmic drama playing out on the grandest of scales, a drama in which we are all participants, whether we know it or not. The question of our universe's ultimate fate has captivated humanity for millennia, but only recently have we begun to gather the clues needed to piece together the puzzle. We now understand that our universe is not static. It is a dynamic, evolving entity. The space between galaxies is growing, a discovery that reshaped our entire understanding of reality. But the story doesn't end there. The expansion isn't slowing down as one might expect. It's speeding up. Something is pushing everything apart, an invisible energy woven into the fabric of space-time itself. So we must ask the question, what happens if this acceleration doesn't just continue, but goes into overdrive? What would that mean for the galaxies, the stars, and for us? Imagine the quiet hum of an engine that has been running in the background for billions of years, a hum so constant it has become part of the silence. Now imagine that hum suddenly roaring to life, growing louder and more powerful with each passing moment. This is the scenario we are contemplating. A sudden, violent increase in the power of dark energy would trigger a chain of events so catastrophic, it would redefine the very meaning of existence. It would be an unraveling of reality as we know it, a cosmic story reaching its final breathtaking chapter. So what is this mysterious force we call dark energy? In the simplest terms, dark energy is the name we give to the unknown phenomenon that is causing the universe to expand at an accelerating rate. It appears to be a property of space itself. This means that as more space is created through expansion, more of this energy comes into existence, creating a kind of feedback loop. Think of the universe as a giant loaf of raisin bread dough rising in an oven. The raisins represent the galaxies, and the dough represents space. As the dough expands, all the raisins move farther apart from one another. Now imagine that something within the dough itself is causing it to rise faster and faster. That something is analogous to dark energy. It isn't pushing the raisins directly. It's acting on the dough, the very fabric of space-time, making it stretch at an ever-increasing velocity. For much of the 20th century, astronomers believed the expansion of the universe, initiated by the Big Bang, must be slowing down. The collective gravity of all the matter in the cosmos should be acting like a brake, gently pulling everything back together. No one was prepared for the truth that observations would reveal at the turn of the millennium. The discovery of dark energy was a profound shock to the scientific community. It came from observing distant supernovae, exploding stars that act as standard candles for measuring cosmic distances. To truly grasp the significance of dark energy's acceleration, we must first appreciate the current state of our expanding universe. For the first several billion years after the Big Bang, the universe was a very different place. It was smaller, denser, and the force of gravity was the undisputed king. This gravity worked to pull material together, forming the first stars and the great cosmic web of galaxies we observe today. During this era, the expansion of the universe was actually slowing down, just as physicists had long predicted it would. However, there was a tipping point in the history of the cosmos. It occurred roughly 5 billion years ago, around the same time our own solar system was beginning to form. As the universe continued to expand, the density of matter decreased, because the same amount of stuff was spread out over a much larger volume. But the density of dark energy, being a property of space itself, remained constant. Eventually, the repulsive force of dark energy began to overpower the attractive force of gravity. This was the moment the cosmic engine shifted gears. The expansion of the universe stopped slowing down and began to accelerate, a state of affairs that continues to this day. This ongoing, gentle acceleration is the backdrop of our current cosmic era. It means that distant galaxies are receding from us at ever-increasing speeds. In fact, galaxies beyond a certain boundary, known as the cosmic event horizon, are already moving away from us faster than the speed of light. The light from those galaxies will never reach us. They are, for all practical purposes, lost to us forever, their light redshifted into oblivion. Our observable universe is, in a very real sense, shrinking. The future it paints is one of increasing isolation. One by one, distant galaxies will slip beyond our cosmic horizon, their light fading from our sky until, trillions of years from now, our own Milky Way galaxy and its nearby companions in the local group will appear to be a lonely island in an endless empty void. It would be a quiet and desolate end, a big freeze where the universe becomes cold, dark, and empty. But this serene, lonely future is based on the assumption that dark energy remains constant. What if it doesn't? What if the engine's quiet hum is just the prelude to a deafening roar? Let us now introduce our terrifying hypothesis. Imagine that today, on August 3rd, 2025, something changes in the fundamental nature of dark energy. Perhaps it's a phase transition, like water turning to steam, or perhaps a new field of energy awakens in the vacuum of space. Whatever the cause, the effect is immediate and terrifying. The repulsive force of dark energy begins to grow stronger, rapidly. This isn't the gentle, constant push we currently observe, but a runaway acceleration. The cosmic engine, which has been humming along steadily for 5 billion years, suddenly redlines. The fabric of space-time begins to stretch not just faster, but at a rate that is itself increasing exponentially. This scenario is known to cosmologists as the Big Rip, and it represents one of the most violent possible ends for our universe. The name is chillingly descriptive. The growing force of dark energy would begin to systematically tear apart all gravitationally bound structures, starting with the largest and working its way down to the very smallest. Unlike the slow fade of the Big Freeze, the Big Rip would be a swift and definitive end to everything. The change would not be immediately obvious to us here on Earth. The initial effects would play out on the largest cosmic scales, far beyond our direct perception. The first casualty would be the cosmic web itself, the vast superclusters of galaxies that form the largest structures in the universe. From our vantage point in the Milky Way, the initial signs would be subtle, detectable only by our most advanced telescopes. Astronomers would notice that distant galaxies were accelerating away from us far more rapidly than predicted. Every measurement of the universe's expansion would return impossible numbers, indicating that our understanding of cosmology was not just incomplete, but catastrophically wrong. As the runaway acceleration of dark energy continues to build, the effects would cascade down from the cosmic superclusters to individual galaxies. Our own local group, a modest collection of galaxies including the Milky Way and Andromeda, is currently bound by gravity. In fact, Andromeda is on a collision course with us, destined for a spectacular merger in about 4.5 billion years. But in a Big Rip scenario, this cosmic dance would be cancelled. The rapidly expanding space between our two galaxies would begin to counteract our gravitational embrace. The approach would slow, halt, and then reverse. Andromeda would appear to stop in its tracks and then begin to recede from us, forever. What was once a universe of neighbors would become a universe of strangers. Within a few million years of the acceleration beginning, a mere blink of an eye in cosmic time, the force of dark energy would become strong enough to start dismantling the galaxies themselves. The Milky Way, a majestic spiral disk of hundreds of billions of stars held together by gravity, would begin to break apart. The stars in the outer arms would be the first to go. The space between them would stretch so powerfully that the galaxy's gravitational pull could no longer hold on. They would be flung out into the rapidly growing void, becoming lone wanderers in the dark. Our galaxy would start to look like a dissolving celestial pinwheel. The process would be relentless. As the stars of the outer spiral arms are cast off, the destructive force would work its way inward toward the dense galactic core. Star systems, once part of a grand swirling city of light, would be ripped from their orbits and scattered. The beautiful, coherent structure of our galaxy would disintegrate into a chaotic, expanding cloud of orphaned stars. For any civilization looking up at their sky during this time, they would witness the stars of their own galaxy flying away from them. The familiar constellations would distort and then vanish, as their constituent stars are torn from their celestial moorings and cast into the darkness. The cosmic devastation would not remain a distant astronomical phenomenon for long. As the Big Rip scenario progresses, the scale of its destructive power would shrink, moving from intergalactic space to the confines of our very own solar system. This is where the consequences become truly personal and immediate. The sun and its planets are bound together by gravity, a force that feels immensely powerful to us, easily holding our world in a stable, life-giving orbit. But in the face of an exponentially growing dark energy, even the sun's immense gravity would prove insufficient. The storm would have finally arrived at our front door. Decades, or perhaps just years before the final end, the effects would become noticeable. The orbits of the outer planets, Neptune, Uranus, Saturn, and Jupiter, would begin to spiral outwards. The space within our solar system itself would be expanding so forcefully that the sun's gravitational leash would start to fray. Astronomers, if any were left, would track these planets moving away from us at an anomalous rate. The finely tuned clockwork of our solar system, which has operated with beautiful precision for billions of years, would be thrown into chaos. The familiar celestial paths that have guided navigators and inspired poets would be broken forever. The unravelling would continue to move inwards. Mars, the asteroid belt, and then, terrifyingly, the Earth itself would be next. Our planet would be pushed away from the sun. The delicate orbital balance that gives us our seasons and a stable climate would be shattered. As Earth's orbit expanded, the sun would appear smaller and dimmer in our sky. The planet would grow colder, the oceans would begin to freeze, and life would enter a desperate final struggle for survival in a world rapidly descending into a deep freeze. This would be a new and ultimate ice age, driven not by geological cycles, but by the very fabric of space tearing itself apart. Finally, just minutes before the end, the force would become so great it would overwhelm the gravity of the Earth itself. The planet would be torn apart. The ground beneath our feet would rupture as the space it occupied expanded violently. The atmosphere would be stripped away into the void. The Earth would disintegrate into a torrent of rock and magma, no longer a world, but an expanding cloud of its own constituent parts. In the final, terrible moment, the sun itself would meet the same fate, its immense gravitational cohesion overcome as it too is ripped apart. Our star, the source of all our light and life, would be extinguished. In the final fraction of a second, the scale of the destruction would shrink to the subatomic level. The force of dark energy's expansion would have become almost infinitely powerful. Having dismantled galaxies, stars, and planets, it would turn its attention to the very building blocks of matter. The electromagnetic force, which binds electrons to atomic nuclei, would be overwhelmed. Atoms themselves would be ripped apart, their electrons torn away, leaving a chaotic soup of nuclei and free electrons. All the structures that make up our physical world, the air, the water, the rock, the remnants of life, would cease to exist, dissolving into their fundamental components. This process of destruction would be absolute and final. There would be no refuge, no escape. The strong nuclear force, the most powerful of nature's fundamental forces, is what holds atomic nuclei together, binding protons and neutrons in a fantastically strong embrace. Yet even this incredible force would be no match for the runaway power of dark energy in the final moments of the Big Rip. The nuclei themselves would be torn apart, shattering into a spray of individual protons and neutrons. Matter as we know it in any form would be completely annihilated. The universe would become a sea of elementary particles that are no longer able to interact with each other. The end would be unimaginably fast. The time between the Earth's destruction and the dissolution of atoms would be shorter than the blink of an eye. The universe would not just become empty, its very substance would be eradicated. Each fundamental particle would find itself utterly alone in an infinitely expanding void. The space between every single proton, neutron, and electron would be growing at a speed far exceeding that of light. No particle would ever be able to interact with another again. The story of the universe, of evolution, complexity, and consciousness would be over. In this final state, the very concept of time might lose its meaning. Time, as we experience it, is linked to change and the progression of events, what physicists call entropy. But in a universe where every particle is isolated and no interactions can ever occur again, what is there to mark its passage? The cosmos would enter a state of ultimate dissolution. No structure, no matter, no energy, no information. Just an infinite expanse of nothing, expanding infinitely fast. The Big Rip is not just an end to life or to stars, but an end to physics itself. It is the ultimate unraveling of reality. To understand why a runaway dark energy scenario is so devastating, it helps to see the universe as being shaped by a grand cosmic tug-of-war. On one side, you have the force of gravity. Gravity is the great architect of the cosmos. It is an attractive force that pulls matter together, building things up. It sculpted the primordial gas clouds into the first stars. It gathered those stars into the vast cities we call galaxies, and it holds planets in stable orbits around their suns. Gravity is the force of cohesion, of structure, and ultimately, of complexity. Without it, none of the wonders we see in the universe would exist. On the other side of the rope is dark energy. Dark energy is the great decomposer. It is a repulsive force, a property of space itself that pushes everything apart. It works in direct opposition to gravity, seeking to smooth everything out, to dilute matter and energy across an ever larger canvas. For the first 9 billion years of the universe's history, gravity was winning the tug-of-war. The expansion of space was slowing down, and structure was forming everywhere. The universe was getting more interesting, more complex, with every passing moment. It was in this gravity-dominated era that our own solar system and the conditions for life on Earth were born. The current state of our universe represents a delicate, shifting balance in this cosmic competition. About 5 billion years ago, dark energy began to gain the upper hand on the largest scales, causing the cosmic expansion to accelerate. However, gravity still reigns supreme on smaller scales. It still holds galaxies together, it still holds solar systems together, and it still holds you and me together. We live in a special time where both forces are playing a crucial role, a dynamic equilibrium where structure can exist, even as the space between those structures grows. Our existence is a testament to this temporary and fragile balance. The Big Rip scenario is what happens when one side lets go of the rope and the other pulls with infinitely increasing strength. A runaway acceleration of dark energy means the tug-of-war is over. Dark energy doesn't just win, it obliterates the competition. It systematically overcomes gravity on every single scale, from the largest superclusters down to the smallest atomic nuclei. The force of construction is completely overwhelmed by the force of deconstruction. The universe that had spent 13.8 billion years building magnificent, complex structures would see them all dismantled in a fleeting moment. It is a stark reminder that our existence hinges on a cosmic balance that we are only just beginning to comprehend. While the Big Rip is a terrifying and spectacular thought experiment, it is important to remember that it is just one possibility among many. Our current best measurements suggest that dark energy is constant, not increasing. If that holds true, our universe is headed for the much quieter, colder fate of the Big Freeze. The truth is, we simply do not know the true nature of dark energy. It is a profound gap in our knowledge, a giant question mark hanging over the future of reality itself. And in that ignorance, there is a deep and humbling sense of wonder. We are explorers who have just arrived at the shore of a vast, unknown ocean. This exploration into the deepest questions of existence is what drives science forward. We build colossal telescopes, intricate particle accelerators, and complex mathematical models, all in an effort to catch a glimpse of the underlying reality. We are a part of the universe that has evolved the capacity to question itself. We look out at the cosmos, and we see not just points of light, but the history of creation, the laws of physics in action, and the mystery of our own origins. Thinking about the end of the universe, whether by fire or by ice or by a violent rip, forces us to appreciate the preciousness of the here and now. The universe is under no obligation to make sense to us, and yet we try. We are driven by an innate curiosity to understand our place in the cosmos. The story of dark energy teaches us that our common sense view of the world is beautifully, wonderfully incomplete. It reveals a universe that is stranger, grander, and more mysterious than we could have ever imagined. It is a universe where 70% of reality is composed of something we cannot see, touch, or comprehend. A force that is silently determining the ultimate fate of everything that has ever been or ever will be. So the next time you look up at the night sky, remember the cosmic drama playing out in the darkness between the stars. Remember the invisible engine of dark energy and the delicate tug-of-war that allows our world to be. We live in a fleeting moment of cosmic equilibrium, a brief warm afternoon in the lifespan of the universe. The future is uncertain, and the greatest mysteries remain unsolved, and that, perhaps, is the most wonderful thing of all. The journey of discovery is far from over. There are still wonders waiting to be found in the dark.